This is part 3 of the exam review, polynomial radical power function review. We're going to start by just looking at the graphs. I know this may be difficult to see, but you should have it in your paper, so hopefully that will help. So where is the graph increasing and decreasing in number 1? So I'm going to mark the decreasing parts in red and the increasing parts in blue. So it should be easy to see at that point that you are increasing from -1 till +2. So from -1 to +2, and decreasing from -4 to -1, -4, -1, and then again from 2 till 5. So 2 till 5. So remember, when you're talking about intervals, you're always talking in terms of the x-axis. Doesn't matter what the y values are. What matters is the x-axis. So again, on number 2, increasing and decreasing, we start with the decreasing part, and then we mark the increasing part. So it is increasing from -infinity. Again, it doesn't stop going that way. So -infinity all the way till 0, and then decreasing from 0 all the way out to infinity. Okay, now let's, just because it's up this way, we'll do 5 and 6 next. State the max and mins. Well, I see a minimum there and there. So the minimums would happen at -3, 1 and +3, 1. The maximum is right here, and that is at the point 0, 4. 6 says state the x and y intercepts. X-intercepts at the x-axis, there'd be one at -4 and at 2. And y-intercepts at the y-axis, so that would be at -3. So if you need to check those answers longer, I would suggest you pause. And now we'll look at the second half. Number 3, state the domain and the range. Remember, domain is the x-axis. So domain starts here at -4, goes over here to +4. But I have an open circle at -4, so I use a parenthesis. Then a closed circle at +4, so I use a bracket. Now the range is the y values. It starts way down here at -4, but it does hit -4 actually. There's no open circle there, so I put a bracket. And it goes all the way up to +4, which does have an open circle, so I put a parenthesis. Domain is x, range is y. So 4, state the domain and range. It doesn't appear to ever stop going left or stop going right. So our domain is -infinity to +infinity. There's nothing restricting us from the left and the right. However, in the range, we never go lower than -3. So I will have a bracket because it does not have an open circle there. But it goes up forever and ever, so I put infinity as my other mark. Now 7 says find the value of f of 2 in the graph below. F of 2, so we find where x equals 2, look at it on the graph, it hits right there at 3. 8, is the graph below a function? Yes, it is. If you recall, you just need to use the vertical line test to determine that there's nowhere that it would hit a vertical line more than once. So I'll do my best to draw a vertical line and then see if it'll let me drag it. Okay, so you can see as this passes along, it never hits the graph in more than one point at a time. So that does pass the vertical line test, which means yes, it is a function. Now you can ignore this right here. You can determine this in your calculator if you'd like. We actually didn't do this semester. This was a leftover from something else. So moving on to the next part. Oh, wrong part. Let's see. Okay, here we go. Number 11. It says find the zeros by hand. So we set this equal to 0. We set each individual piece equal to 0. Okay, 5 equals 0 makes no sense. I'm going to ignore that. Here I add 7 to both sides. Here I take the square root of both sides, and square root of 0 is just 0. So then I subtract 2, and I get 7 and -2. Now in number 12 it says use your calculator, so I want to show you again how you can do this in the calculator. So we'll put x to the 4th minus 9x squared. go to my graph. Okay, now you can hopefully see that there are 3 zeros here. 1, 2, 3. So I'm going to go to second calc 0. I'm going to trace the first one. So I need to go to the left of that first one. So hopefully I can get that to happen. There we go. There's my cursor. I just moved it to the left. Okay, now you can't see it, but it's I kept moving it left, so it's to the left. Hit enter, then move to the right of it. So now you can see I'm to the right of it. Hit enter, enter again, and it's at -3. So one of my zeros is at -3. Now if you try this with the middle one, you're going to run into a problem. It's probably going to say no sign change. And that's because it doesn't actually cross the x-axis, it just touches it. So there's two ways you can approach this one. First, let's make sure this doesn't work. Okay, that's what I thought. It's no sign change. So two ways you can approach it. It looks like it's hitting 0, so if you want to go to your table, just plug in 0, and hey, that confirms it for you. It does in fact hit 0. That's one way to do it. Another way is, even though it doesn't cross the x-axis, it is clear, it should be clear, that that's a maximum. And so if you do second calc and then ask it to find a maximum, you can do the exact same process and it will tell you where that point is on top. Okay, and I know that it doesn't look like 0, 0, but it is. Your calculator is just being dumb and not being very precise. But anytime you see those e's with negative numbers, that means really tiny stuff. So you can just go with 0 on that. Okay, so then the last one, second calc, 0. We want to move just to the left of it. Okay, there I am. Enter, and then to the right of it, hit enter. Enter on guess, and I get 3. So it'd be -3, 0, and +3 for number 12. -3, 0, and +3. So make sure you know how to use that in your calculator. Number 13, we're solving for x. My first step would be to add 10 to both sides, square both sides to get rid of that square root, subtract both sides by 5, and divide by 5 to get x equals 19. Remember, if I'm going too quickly for you, you can always pause and look over it that way. 14, we have x equals 2 squared of x, so I'm going to square both sides to get rid of that square root. I get x squared equals 4x, because I have to square the 2, which makes it 4, and the square root of x. So then subtract 4x from both sides. Say, okay, what do those two have in common? That would be an x. And then set both of those equal to 0. X equals 0, x minus 4 equals 0 gives you x equals 4 when you add 4 to both sides. So you get 0 and 4 as your answers for number 14. Now here we have to get rid of the exponent 3/2. To get rid of an exponent, you raise it to an exponent that is its reciprocal. So I'm going to raise both sides here to the power of 2/3. So the 2/3 cancels out the 3/2, leaving x minus 4. And you can do in your calculator 27 raised to the 2/3. Make sure. Here we go. It gets 9. Then we add 4 to both sides. We get x equals 13. Okay, finally number 16. I have this plugged in on my calculator already in the stat plot. So it says use your calculator to run a power regression. So a power regression, you go to stat, calc, and then you go all the way down to, I think it's 0 or A or something down that direction. So let's see where it is. There it is, A. So that's the power regression. And just because it's a good habit, I'm going to do vars, y vars, function, y1. And so that way it'll automatically plug it into y equals for me. So notice again, it always shows you up here what the form is. A times x raised to the b in this case. So a times x raised to the b. We get 5.06 times x raised to the 0.33. 5.06 times x raised to the 0.33. oh, actually, excuse me, my number says round to the nearest tenth in the direction, so 5.1 x to the 0.3. We'll do that. Now, using the equation from part A, estimate the pay per hour for someone who's worked for 8 years. So 8 years, that's our x, so we would do 5.1 times 8 raised to the 0.3. Oops, sorry about that. Let's see. 5.1 times 8 raised to the 0.3. And we get approximately $9.52 per hour. $9.52 per hour. And then C says, using this equation, estimate the number of years worked for someone who's paid $16 an hour. So the equation, I should write it this way, y equals 5.1 x raised to the 0.3. And if someone is making $16 an hour, we want to find x to know how much they worked. Okay, there's a couple different ways you could solve it. I would recommend dividing by 5.1 first. So I get 16 over 5.1 equals x to the 0.3. Just like we got rid of the 3 halves by raising it to the 2/3, I can get rid of the 0.3 by raising it to the 1 over 0.3. So that will cancel this out, and if I just plug in this to my calculator, I should have my answer. So let's see. There it is. So parentheses 16 over 5.1 parentheses raised to the 1 over 0.3. And we get 45.2 years. 45.2 years.